Hey guys, in this video we are going to build a sentiment analysis API using our pre-trained BERT model, and we are going to deploy all of it behind a REST API using FastAPI and the server Uvicorn. So let's start with a simple demo in which we are going to have a look at what the REST API is gonna look like. And I'm going to go to this project of mine. This is from the GitHub repo. I'm going to start the project and now it says it's running. I'm going to open up a new tab and I'm going to take a review from this app. Tick tick. So let's just hunt for some of the newest reviews right here. And let's get this one. So it has 4 stars. Let's try it. HTTP Py. And I'm going to send some requests with the HTTP Py library. And our model says this is the response. We have a confidence, we have sentiment, which is positive, which is correct, and we have very high confidence in our model that this is actually positive sentiment. And let's try with negative ratings. Let's try this one, bad and have ads. So if I put in the text for this review, we are getting a negative, which is great, and we have a very high confidence again. If I go to the 3-star category and let's try this one. Need some options and need to be more organized something. So again, this states that it is a neutral sentiment, which is again correct. So let's see how we are going to build all of this. I'm going to create this exact same project from scratch, and we are going to step through everything that is required to create this REST API. So let me go open up a new tab right here and close everything here and here. And I'm going to go to a new directory, create a directory called BERT sentiment analysis. Okay. And now that I'm here, I'm going to start Visual Studio Code in that and increase the font for you guys. So this is completely empty project, and I'm going to go ahead and copy the contents of the pip file right here. We are going to use pipenv to create to specify the dependencies, and you can see that we have black, isort, flake8, gdown, and we have most of the packages that are required for the running the application are going to be FastAPI, Uvicorn, Pedantic, Torch, and Transformers. And I'm going to come and explain what those are in just a sec. So let me go here, create a new file called pip file, and I'm going to paste everything here. If you're wondering what extensions I'm using, at least for this one, I'm using the Python extension, which is provided by Microsoft, and I'm using the Vim emulation for Visual Studio Code because, well, I like Vim. So now that we have the pip file, I'm going to say that I want to use the 3.82 version of Python using pyenv local. And next I'm going to install the dependencies, including the dev ones, including using pipenv. So while this is running, let's see what those dependencies are. So FastAPI is a framework for building APIs, and most notably at least they say that is as fast with as fast as Node.js and Go. And what I like about it the most is that it really has a very simple and clean API. So it's easy to use, and yeah, I've been using it for the last couple of days. I haven't got any like real world experience with it, but I think at least for the purposes of this demo, it's a very good framework to create fast and simple APIs. Next, we have our server, which is the lightning fast ASGA server, and the name of it is called is Uvicorn. You might be familiar with the Unicorn server. So now you have the Uvicorn server, and basically this is a SGI server which adds or supports asynchronous programming. And there is a really good example right here. You can use the async and await commands in Python. So this is really good in practice, but for this demo, I'm not really going to take any advantage of using the sync and await commands. Next, we have pedantic or pydantic. So this thing is basically enforcing some data validation during runtime for you. And I find it really good when, for example, you are trying to type in some things like maybe your request in your response. Next, I'm going to show you the reference repo which is provided by this guy, Martin. Man, I can't really pronounce that name, but thank you. Most of the project is actually dependent on his code, and another one is this repo, which is FastAPI ML Quick Start, which is provided by this guy, I think. So this is Tivadar Danke. Thank you, man. I mean, like, both of those repositories have been a great reference for me to show you how you can deploy BERT. And I'm pretty much following the structure of the code that this guy has. Well, I made some changes to it. I don't really agree with the structure of the project, but still, this guy has provided some great reference, at least for me. So thanks to you guys. Okay, we have the dependencies now installed, and I'm going to run pipenv shell so that we are making sure that the environment is actually running with the correct virtual environment. Okay, I'm going to go to the VS Code project, and here I'm going to create a new folder called bin, and here I'm going to define a script which is going to be download model. The first thing that we need to do in order to run with everything is you basically might want to just start with an API, but I want to make sure that I am able to download the model, and I'm going to paste in the script. This basic Python script and imports gdown, which we are going to use to download the pre-trained model weights or the pre-trained model state from my personal Google Drive, and I'm going to save the results into assets model state dict.bin. So I'm going to go ahead and create we can use actually I'm going to go to the terminal, make the directory assets, and I'm going to allow the bin download model to be executable. And next I'm going to run it. So this should go ahead and start downloading our model. Okay, during this time, I'm going to create a new folder, which is going to be the main folder that we are going to use to create our source code into. And I'm going to specify that the name of this is going to be Sentiment Analyzer. So here I'm going to make a new file called api.py, and this will be the REST API. This will contain the REST API for our model at least. And you might notice that linter plint is not enabled, and some other stuff might come up, but we are just having these files, these dependencies. We have black, isort, and flake8. So to make everything work right here, I'm going to go to the project once more, and I'm going to paste to get the source code of this flake.8 config file. And I wanna give a shout out to my colleague Mumchiu, which basically shared his configuration files for Flake and Black. So thanks Mumchiu, and for isort as well. So this will make sure that the code is properly formatted, and I want to edit only the settings for this project. So I'm going to create a new folder called .vscode, and here I'm going to specify the settings.json. So this is great, and I want to copy the VS Code settings from my GitHub repo. So this should give us the proper configs. So this should be working now. I'm going to exit the code editor and run it again. So if I go to the api.py and close other directories, you can see that we have the proper virtual environment, and we no longer get the warning for linting. Here I'm going to start with a stubbed API, so it will just return a stubbed response. And I'm going to import the FastAPI. We are going to create an app from this. And I'm going to define a request handler. And this one is going to take a request and do something. Here I'm going to take an advantage of the pedantic data validation. And you've seen that when I save this, the formatting is automatically enabled or done for us. And I want to import from pedantic the base model. So we are going to define two classes that are going to represent the request and the response for our predict post handler. This will be just the base model, and this will contain a text which is going to be string. So we are going to take advantage of the Python typing hints, and I'm going to define sentiment response. Here we are going to basically define everything that I've shown you into our demo. So those will be the probabilities. This is going to be a dictionary, and I'm going to need to import that. We're going to have a sentiment, which is going to be just a string, which can be sum of negative, neutral, and positive, and the confidence, which is the probability from our softmax function from our model. And I'm going to import from typing the dict typing annotation. Okay, so once this is saved, you can see that again the formatting is properly applied, which is just amazing. So now we are going to use the request and response models. So I'm going to specify response model here, sentiment response, And for the request, I'm going to just say sentiment request. So this will make the typing for us. And here I'm going to return a stubbed version of the sentiment response. So the sentiment for this at least version is going to be neutral. The confidence is going to be high, like 99%. And the probabilities are going to be this dictionary using negative equal to 0.005. Neutral is going to be 0.99. And positive is going to be 0.005 again. So we have some error here, but that's okay. So everything should be working now, and I'm going to try out to start our server. And to do that, I'm going to just create a new script here, which is going to be named start server. And I'm going to go and copy and paste the script contents from my repo, because every time I'm forgetting about it. So another bash script, we have the server running Uvicorn, we are going to the sentiment analyzer, then to the API, and we are referencing the app variable. All right, let's give this a try. So I'm going to use these to allow our server to run. And it says that it's running here. Okay, I'm going to open up a new tab, and here I'm going to use HTTP Py. I'm going to send a post request to this URL, predict, and here I'm going to specify the text, which is going to be, for these purposes, hello world. And you can see that we are getting our final result, or the response from our stubbed API. So this is great. And next we are going to add our model to this API. So we are going to predict some really useful sentiments. Adding our model to the project might seem easy at first, but we have to take into account that BERT is used, and to get predictions from BERT, you need to have some sort of pre-processing done. So for this, we are going to create a facade, or some kind of abstraction of the logic that is required to convert text into a prediction using BERT. And this facade is going to be using our sentiment classifier model that we've defined into our previous video. Here we are going to need to redefine this. So let me start with that. I'm going to create a folder called classifier. And here I'm going to create a file called sentiment classifier.py. So here I'm going to define our model. That is based on Torch. I'm going to import this. And I'm going to need the BERT model here as well. Recall that into the constructor we were requiring the number of classes. I'm going to call the super constructor. I'm going to define the BERT model. And here we need something to tell us what is the type of model that we are using. And for that purpose, I've went ahead and created a config file, which is basically, well, this might have been an earthquake. So into the config file, config.json, we are specifying a BERT model, the pre-trained model path that we've downloaded, the class names, and the max sequence length. All right. So now that we have the config, we are going to use the JSON right here, library. I'm going to open up the file. And store it into a variable. All right. I'm going to get the BERT model from the config. I'm going to define a dropout layer. And recall that we've used a probability of 0.3. And we have an output layer, which is just NN linear. And the number of input units is going to be defined by the config into the BERT model. And the output is going to be the number of classes that we have. So this is great. And next we need to define the forward function, which takes the input IDs and the attention mask. Here we are going to call the BERT model, get the put output, run this through our dropout layer, and return the results from the output layer. All right. I'm going to take the output of the dropout layer and return the output of this model. And next we're going to continue with the facade for our sentiment classifier. I'm going to create a new file called model.py, and in it I'm going to use the BERT tokenizer and the sentiment classifier that we have. But first I'm going to jump right here and take the config file loading. So this is pretty much everything we need, except that I'm going to import torch as well, and I'm going to need the functional module from NN as F. So we are going to apply our softmax function right here. Okay, so let me define the class, and it's just a Python class. Here I'm going to start with defining the device on which the computation is going to take place. And this will be CUDA at index 0 if torch CUDA is available. CUDA is available, else this is going to be just a CPU. Okay, so let me fix this. I'm going to create a tokenizer, BERT tokenizer from pre-trained, and again I'm going to use the BERT model from the config. Next I'm going to create a classifier instance, and this is going to be the sentiment classifier, and I'm going to need to import that. And this takes the number of classes, which are going to be the length of the class names that we have. And next I'm going to load the weights for our model, which are already downloaded from the Google Drive. Pre-trained model. So this will point to this file right here. And I'm going to specify another parameter, which is map map location. And I'm going to map the results from this to the device that we're using. And this is required because you might have trained your model on the GPU and then save that, and then you want to make inference on the CPU or another device, I don't know, and then you will need to pass in the map location so that the data is, I guess, properly read from that model state. Next, I'm going to put the classifier into evaluation mode, because yeah, we are just going to use it for inference. And then I'm going to create a field for it and move it to the device itself. Okay, and this model class has only a single method, which is this called predict, and this will take just a single parameter called text. So this will be the text of our review. First, we need to encode the text using the tokenizer, and I'm going to use the encode plus method. I'm going to pass in the text. I'm going to pass in the max length here, max sequence length. I want to add the special tokens. I want to return token types ID to be set to false, so because we don't really need those. I want to path the sequences. I want to return the attention mask, and I want to return PyTorch tensors. Okay, so I'm going to take the input IDs from here, and I'm going to move those to the device. I'm going to do the same thing for the attention mask. And I'm going to use torch no-grad to probably speed up the computation a bit. And I'm going to take the probabilities or the prediction from our model using self.classifier. I'm going to pass in the input IDs and the attention mask. And recall these are not probabilities, so we have to apply f softmax to the result of this. And I'm going to apply that along the first dimension. And this pretty much gives us the prediction from our model. Next, I'm going to take the most confident result or sentiment using torch max, and I'm going to pass in the probabilities, and I want this again along the first dimension. So the predicted class is going to be moved to the CPU, and I'm going to take just the item, so just the round number. And the probabilities, I'm going to remove an extra dimension that they have and just get a list from that. All right. Finally, I'm going to return the name of the sentiment using the config class names and the predicted class. I'm going to also return the confidence, and I'm going to return a dictionary containing the class names along with the probabilities or the predictions of our model. So this gives us the complete model class, and you can see that it's pretty lengthy, but this is mostly because we are required to do a lot of pre-processing for our BERT model. Next, I'm going to create a single instance from our model and define a function called getModel. And I'm basically doing this because the initialization of our model is a really heavy or computationally expensive task. So we are going to use another design pattern. We're going to use the singleton pattern, We are just creating a single instance of the model, and we are going to use this function called getModel to return that single instance. Okay, so we have our model and we are ready to put everything together. To do that, I'm going to get back to the api.py file and I'm going to import the model itself. And I'm going to import the getModel function. All right, but why do we need the model thing? Well, I'm going to use dependency injection that is provided by the FastAPI library. And to do that, I'm going to need another import, which is depends from the FastAPI package. And right here, I'm going to say the dependencies of the model is going to be provided by the getModel. So this will make sure that the injection of this parameter model is done by the function getModel. Now that we have this, I'm going to call model.predict and I'm going to pass in the text of our review, which is taken from the request itself. So this will return the sentiment, the confidence, and the probabilities. And I'm going to replace all of this dummy data right here. Okay, let me run this like it. All right, so the formatting has been complete and now we should have our API. Let's try it out. Bin start server. So this will just print out a lot of stuff and it says that it's loading weights from the Huggingface and then it should be loading the weights from our own sentiment analysis. Okay, so let's go to the Google Play. Right, let me open up some app. So let's say that we are fans of TikTok, I don't know, and go to the reviews. I'm going to open up all reviews and I want to get like the newest reviews. So let's get this one. Great app with lots of features. Can you please add dark mode? So let's run this. And I'm going to paste this and we're getting a positive sentiment, which is just what you might expect. So this is a correct one. And we have a very high confidence. Let's get some rating, which is not that good. You can see that most of those reviews are very small in terms of words that the users are typing. Let's get this one, for example. And if I paste this, and it says that it is negative, and really it is, and we have a high confidence again. Let's try something that is a bit harder. I'm going to take some neutral review. Let's take this one from Joshua. So it's again correct and it's really confident about it. I mean, like, this is pretty amazing. So now you're ready to deploy your model to production. Well, that's complete bullshit. I mean, like, you need a lot more stuff like monitoring, maybe Docker, you might need Kubernetes, you might need some alerting, you might want to have a way which tells you how your model is doing in production. I mean, like get the predictions, then evaluate those predictions and compare them with the ground truth data. But at least this project will give you a simple way to start this whole process. And depending on the type of project that you're working on, you might really go ahead and just deploy this FastAPI REST API and be done with it. Thanks for watching, guys. I hope that you really enjoyed this video. I'm going to link the text tutorial down into the description along with the GitHub repo. Please like, share and subscribe to my channel. I'll see you in the next one. Stay safe, stay healthy and stay strong. Bye bye.